In January 1941, Charles Cast Iron Charlie Sorenson stood on the sun-scorched concrete of Consolidated Aircraft's San Diego plant and felt a familiar surge of irritation. Sorenson, Ford Motor Company's legendary production chief, had spent a lifetime mastering the science of industrial efficiency. He had helped build the modern assembly line alongside Henry Ford. He understood mass production as well as any living American, and what he saw in front of him made no sense. B-24 Liberators, heavy bombers, urgently needed by a world sliding into war, were being built outdoors, under the unfiltered California sun. Workers hauled parts around by hand. Engines were hoisted into place using improvised rigs. The heat warped aluminum skin panels. Nothing was standardized. One wing might not match the next. Every aircraft required improvisation, shimming, and refitting. After months of work, Consolidated had delivered only 3 complete bombers. The global situation was collapsing. France was gone. Britain stood alone, absorbing nightly air raids. President Roosevelt had just demanded 50,000 combat aircraft, a number larger than everything the U.S. aviation industry had produced in 38 years. But here stood a major aircraft contractor struggling to build a handful of bombers in half a year. The Army Air Corps hoped Ford could manufacture components, just parts, not whole airplanes. But watching the chaotic, handcrafted pace of Consolidated's production, Sorenson instantly knew something deeper. This approach could never meet America's needs.
A B-24 was an engineering behemoth, 67 feet long, a 110-foot wingspan, 4 engines, 10 crew members, and 1.5 million parts. A Ford car had 1% of that. Aviation experts insisted bombers couldn't be mass-produced, too complicated, too precise, too dependent on skilled craftsmanship. But Sorenson saw the same problem he'd solved decades earlier with automobiles. The B-24 wasn't too complex, it was simply being built with the wrong method. The key would be to break the aircraft into standardized assemblies, feed them into a moving line, and let the product travel while workers remained stationary. That night in his hotel room, unable to sleep, he took out a sheet of stationery and began designing a factory. He broke the bomber down into 69 subassemblies. He laid out parallel production lines over a mile long. He penciled in material flow, worker spacing, and timing. When he showed Edsel Ford the concept over breakfast, the younger Ford did not flinch. Ford would build the plant, not parts, entire bombers. Consolidated executives dismissed the plan as absurd. They believed Sorenson did not understand aircraft manufacturing. They insisted airplane tolerances demanded custom assembly. But they could not describe an alternative that would yield Roosevelt's numbers. Sorenson left California having already made up his mind. Ford would take on the biggest manufacturing gamble in American history.
A nation without bombers. The stakes were not abstract. In 1941 and early 1942, the U.S. Army Air Forces faced a crippling shortage of heavy bombers. Training units made do with obsolete aircraft, combat groups shipped overseas under strength. The entire strategy for striking Germany, daylight precision bombing, required hundreds of bombers flying together for defense. But American industry produced fewer than 2,000 heavy bombers in all of 1941. General Henry Hap Arnold warned that at current rates, America wouldn't have enough aircraft for a sustained strategic campaign until late 1944. By then, the war's outcome might already be sealed. Ford's gamble, Willow Run. Sorenson selected Ford-owned farmland near Ypsilanti, Michigan, nearly 2,000 acres that had once been Camp Willow Run, a summer program for fatherless boys. Now bulldozers flattened the woods, and a steam-powered mill turned felled timber into construction material. Henry Ford despised the project. An aging, rigid isolationist, he resented military work of any kind and had resisted defense contracts. But Edsel and Sorenson appealed to his pride and perhaps to his desire to prove experts wrong. Ford reluctantly agreed. Architect Albert Kahn designed the structure as a cathedral production, 3,200 feet long, 80 acres under one roof, with no internal columns. The building was so vast, it dwarfed the floor space of the Empire State Building. Because Henry Ford allegedly refused to let the facility extend into Democratic-leaning Wayne County, the factory bent into a giant L shape. This forced engineers to invent rotating platforms to spin completed fuselages around a 90-degree turn.
Construction began in April 1941 and continued in waves. Even as workers hung steel beams on one end, production equipment was being installed on the other. By September 1941, 3 months before Pearl Harbor, sections of Willow Run were already operational. Then came 20 months of failure. Why everything went wrong? The B-24 was a moving target. Consolidated retained design authority, and the Army Air Forces imposed frequent modifications based on early combat experience. Each change meant new jigs, new tools, new procedures, nightmares for an assembly line that required absolute standardization. Ford engineers sent to San Diego found that the B-24's drawings were incomplete, inconsistent, or simply wrong. Much of the real engineering knowledge existed only in the heads of seasoned consolidated foremen. Sorenson ordered 2 complete Liberators flown to Michigan and disassembled. Over 200 engineers worked around the clock producing new blueprints, sometimes 5 miles of drawings in a single day. But even these were outdated within weeks, overtaken by new design revisions. The most crippling change came when the Army Air Forces demanded a powered nose turret. This required rewriting the bomber's entire nose structure. Retooling took months. Training had to be redone. The first Ford-built B-24H with a nose turret did not roll out until June 1943, 10 months behind schedule.
Meanwhile, Willow Run delivered only 56 complete aircraft in all of 1942, far below expectations. The project became a national punchline, mockingly called Will It Run? A factory without workers. The plant's location became a logistical disaster. 25 miles from Detroit, with wartime gasoline and tire rationing, workers simply could not get there. Ford hired 2,900 people in 1 month and lost 3,100. Turnover reached triple digits annually. Absenteeism ran up to 30%. People quit for easier jobs closer to home. Inside Willow Run, the environment was brutal. Heating systems lagged behind construction. Tools stuck to bare skin. In summer, temperature soared to 100 degrees, turning the sheet metal floor into a griddle. Housing was equally catastrophic. Thousands of workers lived in cars, barns, or in beds rented by the shift. Only when the federal government intervened, building dormitories, trailer parks, and temporary housing complexes, did the workforce begin to stabilize. Yet even these facilities were segregated. African American workers were restricted to a separate, smaller housing development called Park Ridge, despite equal workforce numbers.
A Senate investigation and a turning point. The problems drew federal scrutiny. Senator Harry Truman, chairing a committee on wartime waste, visited Willow Run twice. After extensive investigation, the committee concluded that Ford was not at fault. Consolidated's flood of design changes had crippled production. The committee recommended placing the entire project under the authority of a single manager. This simple administrative shift changed everything. Production takes off. With a single authority in charge and design changes finally slowing, Ford engineers were free to perfect the line. The Army standardized on the B-24J model in spring 1944, ending the chaos of constant redesign. Workforce stability improved as housing expanded. Commute times shortened. People stayed long enough to become skilled. Training no longer evaporated as fast as it was given. Ford engineers optimized thousands of tiny inefficiencies, improving tool placement, redesigning material flow, adding lighting, adjusting work stands. Each tweak saved seconds. Across tens of thousands of workers performing millions of operations, the cumulative effect was transformative. Output began to climb. 37 aircraft in January 1943, 70 in February, 96 in March, 146 in April. By late 1943, Willow Run was the miracle it was meant to be. The 1,000th bomber was celebrated on November 3rd, marking the factory shift from derision to triumph.